Hello everybody. I wanted to do a quick session talking about advanced AI techniques. So one of the most common elements that we've seen within a lot of VR games made this year is people that chase you around. And I think that's a relatively well covered topic. It's covered in one of the previous videos. But what I wanted to look at for the next couple of minutes or so is how to do more complex AI. You can see I've got a happy little zombie currently walking around a series of checkpoints. So I'm going to explain how that works and how we can expand on this to have our enemy either following a set of waypoints, but have them change their state, change their behaviour based on whether they've detected the player, what that might mean, how they could add multiple states, and how they could behave a little bit more intelligently than just chasing the player, which is good for a zombie game but not good for a stealth game and not good for something where you've got to avoid detection. So you can see here I've got my zombie moving around. The zombie is chasing each of these 4 waypoints. So if I go into scene mode, I've got 4 waypoints just represented by flags. In reality they are just empty game objects which I've added children to. They look a little bit like a flag. It's a cylinder and a cube. So what the waypoints is really doing, this is just an empty game object which works as a parent for all of these, so I can keep everything nice and organised. But if I show you how this works, we'll talk about how we can expand on this. My zombie as a game object has a NavMesh agent component attached to it because that's what we need in order to get things to work. And as a quick refresher, you have to go to Window, AI and navigation in order to get the navigation panel up and make sure that you have baked your NavMesh. Remember, AI agents need to walk on a NavMesh, which requires you to bake your NavMesh in advance. If you're not getting this blue baked surface for our AI agents to walk on, you need to make sure that your surface is declared as static in the inspector, otherwise it won't work. So with our AI agent selected, we've got our NavMesh agent component, and I've got a script here called AI movement, which we're going to go through now. This is what that script looks like. Now you could copy paste this if you wanted to, you could copy this out and this would work fine. But what I've got set up is we're using UnityEngine.ai, we need that in our using space at the top, otherwise it won't work. I've also created a public enum which is called enemy state. I'll talk about that a little bit later, but just know that our enemy has 2 states, whether we're following waypoints or whether we're hunting the player. It doesn't do anything at the minute, but I've set it up so it's ready to go. Then we've got our class, and usually anything like this we'd expect to see written inside of the class, inside of under the name, underneath where it says mono behavior. But in the case of an enum, which is great for declaring a state, you'll notice that's outside of it. We'll come back to why that's important, but anyway. Inside of my AI movement script, I've got a public transform array. Notice the square brackets there mean array. So I've got an array of waypoints. I've got a public game object for the player, so it always knows who the player is, so we can potentially chase that. And then the currently selected waypoint, which starts life at 0. All I've got here as well is each zombie, because we could potentially have our zombies spawning in as prefabs. In our start function I'm saying the player is go find the thing tagged with player, and if you've forgotten how to do tags, remember that lives under here. You can create as many tags as you like, or you can call them whatever you like. So I've got one called player for my, in this case, FPS controller, but if you're doing an XR game you'd have the XR origin and whatnot. So I've got that declared as player. So it always finds the thing with that tag. I'm going to just show you this bit to start off with. If you just wanted your AI to chase the player around, that line of code will basically do it. So what I've got here is a line of code that says get the NavMesh agent component, and this is happening on update, so every single frame, get that component and set its destination. Currently I'm going towards the first element of the waypoint target, but if you just wanted to chase the player around, it was as simple as set the destination to, well, wherever the player is, player.transform.position. That line of code will always move it towards the player. So if you just want your enemy to chase you around, done. You don't need anything more complicated than that. But we're looking at advanced AI today. So what we're looking at doing here in this line of code, is set the destination to waypoints. Notice that's the list, the array of waypoints. Currently I've got 4. To the current waypoint target, which by default is set to 0, so the first thing in that list, and go and move towards that. What we've then got is a check. If you're within a certain distance of the current waypoint it's trying to get to, in this case 0.1 meters, so that's 10 centimeters, if you are within 10 centimeters or less of it, then increase the current target. Well, actually what we're doing first here is we're checking, are we currently at our maximum number of waypoints? So this, I have 4 waypoints here, 1, 2, 3 and 4. If I'm at number 4, well I need to go back to number 1. So we just need to make sure that we're going back around in that case. And if you remember, computers don't really start counting at 1, they start counting at 0. So what I'm checking is if the waypoint target, i.e. where I'm currently trying to go to, is that as long as the array? So I've got 4 elements in my array, and I'm minusing 1 from that because I'm going to subtract 1 in a second, so it's important to check, am I not yet at the maximum? If I am about to reach the maximum number, or I'm currently reaching the maximum thing in my array, set the target back to 0, so that will force the loop. If I'm not at the maximum one, just move to the next one in the list. So that's going from, I know I've named these 1, 2, 3 and 4 to be added confusing, but what it's actually doing is going to element 0, 1, 2 and 3. And in the zombie, that's what this looks like. I have an array of waypoints, which I can open up with the arrow. There's 4 elements starting 0, 1, 2 and 3. Whenever we deal with an element, remember it starts at 0. And just for added confusion, I've called them 1, 2, 3 and 4. But remember, we start counting at 0. That's how arrays work. And you can see it will go to the first element, the 0th element, then go to the first element, then the second, then the third, and then back to there. The way these work is if I were to have an extra waypoint, I could position a new waypoint in my thing. This won't know, or the zombie won't know that that is a new waypoint until I drag and drop it into this slot. So instead of waypoint 4, I'm going to rename you waypoint 5. With my zombie selected, I want it to know that there is a new waypoint on my list, and there we go. We can expect it to go and find all 5 waypoints. Let's just double check that that works, and we're going to make our zombie move a little bit quickly because we don't like waiting around very much. A promising start. Let's see if it repeats the loop. Does it return to the 0th element, which it seems to, and then it will continue on our loop. Now this is all well and good if we want something just to go around path, but we need it probably to detect us. So we can have it detect us in a bunch of different ways. We can check, is it within a certain range, has it heard us, is there a ray being detected, or is there visibility? So we're going to cover a couple of different points here, but we're now going to go back up to this enemy state enum, which I created earlier. So we've got these 2 states the enemy can be in, either waypoint, going around, or hunting, meaning they're chasing the player. So we can use these 2 states, and we can have more if we like. We could have idle, we could have however many states we liked, and you would just add them like that. But what we now care about is in our update loop, we only want to do all of this if we are in the waypoint state. So what I'm going to do here is create at the top of our declaration another public, but this time it's going to be a public enemy state. What state is the enemy in? Keeping in mind this zombie represents our enemy. So we're going to create a new public enemy state, which I'm going to call state, and that state is set to enemy state dot, and then I can choose the 2 things that are in my my enum. So I want them to be set to waypoint by default. So now what we can do is every time in the update loop, if the current state of this particular enemy is equal to enemy state dot waypoint, then we do all of this. Problem with this is it's actually starting to get quite difficult to read all of all of this. So what I'm going to do is just move all of this stuff. I'm not going to change what it does, just going to move it into a function. So I'm going to take a cut of that and I'm going to write a function to paste it in. So we're going to call a function now, which I'm going to call something like waypoint motion. And I'm going to put parentheses after that, and I'm going to put a semicolon. And it will go to me, whoa, Dave, you don't have a function, don't have a method. I really should call them methods. It doesn't have a method called AI, inside of here, waypoint motion. Would you like me to create one, please? Yeah, go on then. So that's now created a method called waypoint motion and highlighting, well, I don't know what to do. So I'm just going to delete that and paste in the code we were doing previously. Reason why this is good, this is called compartmentalization, because I can now minimize waypoint motion and it will just go and do whatever we were doing previously. Still there, code is still there, not changed, but it's nice and tidy, and we can compartmentalize things a little bit together. So if we're currently in the waypoint state, we should do the waypoint motion. If I am not, I'm writing an else if here. This is, I could just use an else, but assuming we're going to add more functions later on. If I'm not in that state, am I in the hunt state? And if I am in the hunt state, I'm going to go and do another block of code, which is going to be called perhaps hunt motion. And it's again going to say to me, Dave, you don't have a function, I keep saying functions, method. You don't have a method called hunt motion. Would you like to create one? Yes, please. And that will now go and create one called hunt motion. There's nothing stopping me writing this out myself, but it's nice to get it to do it for me because it keeps things nice and clean. Now, if I'm in the hunting motion, I'm still going to be setting the destination, but I don't care about any of that waypoint business now. The destination will just be the player, like we were doing before. Just move towards the player's position. So you can see that this keeps the update method nice and tidy. If I'm in the waypoint state, do the waypoint motion method. If I'm in the hunt state, do the hunt motion method, and you can see what they do down here. Little tip as well, if you don't know, because we're doing advanced stuff today, if you hold down Control on your keyboard, these things become links. So I can click on waypoint motion and it will take me to it, or I can Control click hunt motion and it will take me to it. Particularly good if you have a lot of code in one file. Thing is, the canny amongst you will have noticed that there's no way of getting into the hunt state right now. There's no way that we can do that. We will always be in the waypoint state because we declared it at the top. We're in the waypoint state and we never change it. As always, I'm going to test that that is true because we always test, we never trust. Firstly, have I introduced any coding errors is always worthwhile. Look at him go! So definitely still in the waypoint state. Going across all 5, nice. But we want them to be able to detect us, and we're going to just do a simple check, are they within a certain distance? So at the top of my update loop here, before I say which state am I in, we're going to do a check. If vector3.distance, which is exactly what I wrote down here in what is now the waypoint motion method for checking am I within 0.1 meters, within 10 centimeters of the current waypoint. I'm going to do the same here, but the things I'm checking is my transform.position. Remember that I am the enemy, that's what we're talking about, my position, so the enemy's position, compared to the player's position, which is a transform.position. And then I want to check. The reason why that's red and angry is because an if statement requires you to compare that to something. So that will return a distance in meters. And then I want to say, well, is that less than or equal to a number? Let's say 1 meter. Remember as well, you can have decimal values, but if you want decimal values, you must finish that off with an F to say that it's a floating point value. So if I'm within 1.2 meters, what do I want to have happen? Well, what I'm going to say is the current state that I'm in will become enemy state dot hunt. So that makes sense. Sorry, single equals. So set it to the hunt state. If I am not within that distance, well, do you know what? I should be in the waypoint motion state. So as always, let's test, never trust. I'll put this code back on screen in a second as well, but obviously you can pause it if you prefer. So there's our zombie hastily running around. I'm going to try and get within 1.2 meters of them, and I'm going to see, does that change their behavior? I've got attack script set up, which is something different, but we're not seeing it changing states. So you can actually see here in the inspector that it's quite soundly staying in the waypoint state. So let's find out why. Every frame, if my position compared to the player's position is less than or equal to 1.2 meters, we go into the hunt state. If I'm in the hunt state, we take part in the hunt motion, which sets our destination to be the player's transform. Now you get to see how Dave debugs code, because this should work. So I'm going to decrease the speed of our zombie, and I'm going to find out why it's not changing state. So if I walk over here, I'm definitely within 1.2 meters. We're still in the waypoint state, and I really shouldn't be. So every frame, if the distance between transform.position and the player.transform position is less than or equal to that, we're in the hunt state, or else we're in the waypoint state. So what I'm now interested in doing to debug this problem is output that number to the screen. So I've just put a debug.log message in there, so I'm going to see what number that's returning. So through the use of handy dandy error messages, and I'm 18 meters away, there or thereabouts. I'm going to get nice and close. I'm now 10 meters away, I'm going to get even closer. I'm 4 meters away. I'm going to keep going. I'm 1.4 meters away. I'm 1.3 meters away. Is it just because I can't get that close? That would make sense. So let's try, can we get within 2 meters? If I were you guys, I'd say this would be a good one for the testing table, right? Can I get within 2 meters? Aha! And you can see it's changing. Now it's in the hunt mode, and now it's going back to waypoint. And then if I get close enough, it's in the hunt mode. Now the problem with this is quite obvious that I have to stay within 2 meters for this to happen. So rather than having an if and an else statement, once they've detected us, they've always detected us. Or if they've detected us, we wait a period of time using an IE numerator, and then it sets it back to whatever it is. So we can try that. So state, we're in the hunt state, and then we're going to call an IE numerator. Well, I should say we're going to call a coroutine. Coroutines is how you go and introduce a delay into something. So I'm going to call a coroutine, and that coroutine is going to be called set back to waypoint. And set back to waypoint doesn't currently exist, so let's go and make one. So I'm going to make another function down here. Unlike the other functions that were private void, this is going to be private IE numerator. What does IE numerator mean? I've still no idea. I've been teaching this 10 years, not a clue. If you followed this far through the tutorial, you deserve to know that piece of information. So, problem with IE numerator is it must return a value. So it must return something. And if we want something to wait a period of time, what we return is a yield. I can never spell yield. New seconds. Okay, we yield before we return, I think. Yield, return, new, wait 4 seconds. What an awful blasted line of code that is. So let's say wait 5 seconds, and then once 5 seconds have passed, what we want to do is to change its state. And we're going to change its state by going state equals enemy state dot waypoint. So that will wait 5 seconds and then return to the waypoint state. But because we're checking every single frame, it will always be in the hunt state unless when it checks we're out of range. So how do I use coroutines? Not like that by the looks of it. Start coroutine. I'm pretty certain I need to do that. That looks a little bit better. So I'm going to start a coroutine, and the coroutine I'm starting is called a setback to waypoint mode. It goes and does it, waits for 5 seconds, and then turns the state into the state that we want. So if I just minimise all of this to show you the methods that we've got in our program right now, we have a method called hunt motion, we have a method called waypoint motion, and we have a method called setback to waypoint. And you can see that the update loop, I can get rid of that debug message. Oh, I'll keep that in just for testing in a second. And let's see if that works. So I'm going to stay some distance away. I'm going to get close, and they're chasing me, and I'm going to walk quite far away, give it 5 seconds, and they return to what they were doing. I'm going to get back within 2 meters. And there you go, we can have some fun with this character now. So as soon as they hear me, because I'm within 2 meters worth of distance, I'm going to dip within a 2 meter distance, and they should follow me for 5 seconds. You can see in the bottom right hand corner in the hunt state, and now we've just returned back to the waypoint state. So if I were to expand this code now, rather than having that hard coded to say wait for 5 seconds, what I'm going to have here is a new public float called wait time, or hunt time. Let's call it hunt time, that's probably a little bit better. And I'm going to set hunt time to be 10 seconds by default, and instead of waiting for 5 seconds, we wait for whatever hunt time is. And because hunt time is public, that will now be available on here. I'm going to just quickly introduce you to one. No, that's not quite going to work. So I was going down one route there and it's not going to work. But I was just saying we could randomise that value was what I was thinking there. So we could use... I'm going to test that this works first. Let's just make sure that that works within a 10-second period of being in the hunt state. So I'm going to get really, really close. They should then chase me, and we can see that the enemy is in the hunt state down here, which should last for roughly 10 seconds. And then they return back to the waypoint state. So that's clearly working, but if we wanted to randomise that number, let's create a random.range. And that random range, why is it not like random? That one, Unity Engine.random. Because that random is a Unity thing and a system thing, it just needed me to say which one I wanted. So Unity Engine.random.range, and notice that it's range, not random range. That one's depreciated, and I know it's depreciated by reading the tooltip. So I want random range, and I'm going to have a random range between, I don't know, 5 and the hunt time. Or I could say the hunt time minus 5 and the hunt time plus 5, which means that it will be between 5 and 10 or whatever it is. I could even create another variable up here for how much variance there is in the random hunt time. But getting ahead of ourselves. As always, we tested it works. I'm going to get danger close. I'm going to see, are they going to chase me? And despite the fact it says 10 seconds over here, that didn't take very long at all, because I'm guessing I rolled low on that random number. So we're still on the waypoint tracking. I'm going to get close to our enemy. And it really doesn't take a long time for it to return back into the hunt state. So I don't like that. So wait for a random range between hunt time, which is 10, and hunt time plus 5. So that should be a range between 10 and 15 seconds. Let's see what that feels like. We're in the hunt state. We're staying in the hunt state, staying in that hunt state, and despite the fact it says hunt time of 10 seconds, remember that is just being used as our base to then randomise it, and then we return it to the waypoint, which is where they were. So, thank you for seeing through this tutorial as far as we got. You can expand on this. Currently it's based purely on if you get close, but you could base it on line of sight through using a raycast, and you can also do some other bits. We've got time. I'm just going to finish off with one last quick thing because it's a common issue. So a common issue that I see is if you're trying to check not just the distance of something, but also if you're within line of sight is a common thing that you may want to do. So I'm going to do that as another if statement, and sometimes you might want to do one or the other. So a common mistake that I make all the time is we create a raycast hit, like we've done a million times before, which I'm going to call hit. Most commonly you will have seen this in the shooting script. So if physics.raycast transform.position, so again a raycast from me being the zombie, being the enemy, and the common mistake that people, including myself, now make is I pass in the player's position. The problem with this is a raycast doesn't go from point A to point B. It goes from point A in a direction you pass in. So if we wanted to create a direction, what we first have to do is keep a record of it. So I'm going to create a new vector 3 just here. I'm going to call this vector 3 direction, and this direction is going to be transform.position, so the enemy's position, subtracted, or then subtract player.transform.position. And what this will do is return a direction. So I may have got this back to front because that's the kind of thing I do, so we'll always test this in a second, but rather than now going between transform.position and the player's position, we go where I am, the zombie, and the direction I'm looking is the direction we've just calculated by subtracting one vector, which is what that is, from another vector. Well, subtracting this vector from this vector. Again, you can pass in your physics.raycast where you want to put the hit information, so I'm going to put that out into the thing that we created called hit, which makes that error go away, and I can also pass in a range that I want, maybe 20. And again, if you wanted that to not be hard-coded, you could create a variable up here, public float detection range, and you could have that pass in. So what we've now got going on here, despite the fact it's looking really quite busy and ugly, I've got a calculation for where the direction is going, which is a simple bit of vector maths, one subtracted another. I've got a raycast hit, and I'm just outputting, performing the physics raycast, and if I'm in line of sight, then we change to the hunt state. But I've currently got two if statements, one nested in the other. Firstly, am I within 2 meters? And then secondly, am I within line of sight? You may want one, you may want both, but I'm just going to bump up the detection range. So what's interesting here is we have to be within 5 meters of distance, but then we must be in line of sight, which has got a range of 20, so maybe they should be the same number. It's not really going to hurt. And then go into the hunt state. As always, check if this works, because there's a fair old chance it won't. Always test, never trust. If you get sick of nothing else this year, get sick of that. However, let's get within 5 meters. It's in the hunt state, so something definitely worked properly. So let's again test this. I'm going to get within 5 meters, but behind the zombie. Well, no, behind will still affect it because it can draw a line of sight, as we saw there. But if I go and hide behind something, so clearly within range we can see his shadow. Will they chase me? Yes. So now they're hunting me, I'm going to get out of line of sight, but still within range. And you can see, gone off to go and do his thing, because we just made line of sight. So I'm going to break line of sight. There we go. Despite the fact we're clearly in range, oh, there we go. I'm going to hide behind this wall. We're in range, we're out of line of sight. And we're still in the hunt state. Literally backed myself into the corner in my own game. There we go, and back to waypoint because I broke line of sight. So, that's not a very robust test, but I would test that in a number of other ways. If you do find you get wonky results, just swap that on the opposite side of the minus sign. I'm pretty certain that is working, but I don't trust my testing this time of night. Okay, thanks again everyone. Any questions, you know where I am. Cheers.